All right, we're on the back side of day 7 notes, and we have more multiple choice questions. Number 5 says in parallelogram ABCD. So let's draw it out. It says the diagonals AC and BD intersect at E. Which statement does not prove parallelogram ABCD is a rhombus? So I'm going to also draw a rhombus. All right, so they're looking for the difference here. Okay? In number 1, they said AC is congruent to BD. AC is congruent to BD doesn't happen in either shape. Both shapes are slanted, so diagonals are not equal. Oh, but they're looking for which one doesn't prove. I would say that might be it. I'm going to go back and erase that. Yeah. So let's hold on to that one. In number 2, AB congruent to BC. That does prove it. All right. In a parallelogram, this side's equal to this one, and this one's equal to this one. Right? But in a rhombus, all sides are equal. Okay? So AB being congruent to BC would prove it. And we're looking for does not prove it. Okay? Number 3, AC being perpendicular to BD doesn't happen in a parallelogram, but it does happen in a rhombus. That's how we get those 4 right angles in the middle. So that would prove it. And AC bisects angle DCB. DCB is this angle up here. In a parallelogram, that is not bisected. But in a rhombus, that angle is bisected. So that would prove that it is a rhombus. So this is the only one here that wouldn't prove that it's a rhombus. Number 6. If ABCD is a parallelogram, which statement would prove that ABCD is a rhombus? So we can keep our same picture from up above. And they're saying angle ABC is congruent to angle CDA. So angle ABC is congruent to angle CDA. That's true in a parallelogram, and that's also true in a rhombus, that those opposite angles are equal. So since both of them have that, that's not the one we're looking for. AC being congruent to BD, those are the diagonals, and they're not going to be congruent in either shape, so that's not the property we're looking for. AC being perpendicular to BD, those are my 4 right angles that happen in the middle of a rhombus, and that doesn't happen in a parallelogram, so I think that's our property. Okay. AB being perpendicular to CD. Well, AB and CD don't even touch to be perpendicular. They're parallel, so that can't be the property because that doesn't happen in either shape. So we're going to stick with number 3. Number 7, a quadrilateral whose diagonals bisect each other and are perpendicular. So diagonals bisect each other happens in a rhombus, in a rectangle, and in a parallelogram. Okay, so we can get rid of trapezoid. Second property is that they want the diagonals to also be perpendicular. That happens in a rhombus, does not happen in a rectangle, and it does not happen in a parallelogram. So we're going to stick with number 1. A rhombus has diagonals that bisect each other and are perpendicular. So number 1. Okay. Number 8. Which quadrilateral has diagonals that always bisect its angles and also bisect each other? So diagonals that bisect the angles. That happens in a rhombus, does not happen in a rectangle, not in a parallelogram, and not in an isosceles trapezoid. So I think we have our answer, but we'll just make sure that it has the second property as well. The diagonals bisect each other, does happen in a rhombus. It has both those properties, so number 1. Number 9, the diagonals of a quad are congruent. So the diagonals are congruent. That happens in an isosceles trapezoid. It does not happen in a parallelogram. It's Slants, diagonals are not equal. A rectangle stands up nice and straight to have congruent diagonals. And a rhombus goes back to leaning, so not congruent diagonals. And the second property is that they do not bisect each other. In a rectangle, they do bisect each other. The diagonals cut each other in half, okay? But they're looking for do not bisect each other. So we're going to stick with our isosceles trapezoid, who has diagonals that are equal, but they do not get cut in half. Number 10, which quadrilateral does not always have congruent diagonals? Okay. So there's 3 shapes that have congruent diagonals. Isosceles trapezoids have congruent diagonals. Rectangles have congruent diagonals. And squares have congruent diagonals. And they're looking for which one does not always have congruent diagonals, and that's our rhombus. We know it leans, and so one diagonal is usually longer than the other. In quadrilateral ABCD, the diagonals bisect the angles. Well, that happens in a square and in a rhombus. Okay. If the diagonals are not congruent, that's a rhombus. Rhombus leans, so his diagonals are not equal, but they do bisect the angles, so we're going to go ahead and stick with choice 3. Okay. All right, I'll see you guys on the back side of notes for a few more questions.